welcome to today's lesson. This is Kaonga Samuel, your friend and teacher. So today I'll just show you how we can work with Bicimals. Now straight away, what is a Bicimal? The Bicimals are base 2 numbers with a decimal point embedded in them. Okay, any base 2 number that has got a decimal point in it is a Bicimal. For example, base 2 numbers, these are numbers that are just have 2 digits, a 0 and a 1. Okay, now what we mean is, if we have those numbers now with a point in them, for example 1 1 0 0.01, this is a Bicimal number. Okay, Bicimal number. Okay, so this is a base 2 number, but this number in totality we're going to say this is a Bicimal. Okay, Bicimal. Okay, so if I have 1.111, similarly this is also going to be a Bicimal. Okay, Bicimal. Now our main concern today is, how do we convert these now to base 10? How do we convert Bicimals to base 10? Okay, converting Bicimals to base 10. So let's look at how we can convert. Okay, let's look at how we can converting Bicimals to base 10. Okay, how do we convert Bicimals to base 10? Let's see. So here I have come up with what I'm calling a conversion system, a conversion table. But before that, let's just look at this. Okay, if I consider these numbers in base 2, okay, which are when I'm in base 2, I'm staying in the powers of 2. Okay, in the powers of 2. So if I say 1 over 2, okay, 1 over 2 is the same as 0.5. Now 1 over 2 power 2 is the same as 1 over 4, which is the same as 0.25. Then 1 over 2 power 3 is the same as 1 over 8, which is the same as 0.125. Okay, then 1 over 2 power 4 is the same as 1 over 16, which is the same as 0.0625. All right, so we can go on and on and on, but let's now jump on to the other part, the base, those that are in the powers of 10. Okay, in the powers of 10. So in the powers of 10, if I have 1 over 10, okay, 1 over 10, this is the same as 0.1. Okay, if I have 1 over 10 power 2, this is the same as 1 over 100, which is the same as 0.01. Okay, if I have 1 over 10 power 3, this is 1 over 1000, which is 0.001. Okay, if I have 1 over 10 power 4, this is the same as 1 over 10,000, which is just the same as 0.0001. Okay, now I want us to notice one thing here. I want you to notice one thing here. Okay, I hope you can see those numbers. I want us to just notice one thing there. So for me to get, if I'm here, okay, I'm at this number there, okay, I'm at this number here and that number there. So for me to get to this number here, I'm going to square. Okay, I'm squaring this number. I'm squaring 0.5 for me to get to 0.25. In the similar manner, for me to get to 0.01, I'm squaring 0.1. Okay, for me to get to 0.125, I'm going to cube 0.5. Similarly, for me to get to 0.01, I'm going to cube 0.1. So this here, we can come up with a conversion table that is going to help us to work with these Bicimals. Okay, so let's come up with this table there. Okay, you can come up with a simple table to just help us simplify our work. Okay, you can come up with a table there to help us, so that as we go into work, we will really understand what we are talking about and it will not give us challenges. Okay, it will not give us challenges there. So let's have this table there. Okay, here I'm going to say base 10. Here I'm going to say base 2. Okay, so I'm going to say, okay, here if I have 0.5, this is a base 10 number, this is equivalent to 0.1. Okay, 0.5 is equivalent to 0.1. Okay, from there 0.5 to 0.1. Okay, so now I'm going to say, for me to come up with the subsequent numbers, I'm going to say, okay, 0.25. So I'm going to square 0.1, it will be 0.01. Here I'm going to cube 0.5, it will be 0.125. Here I'm going to cube 0.1, so it will be 0.001. So here I'm going to power 0.5 to a fourth, which is going to give me 0.0625. So similarly here I'm going to have 0.0001. Okay, this table here will help us a lot. Let's just straight look at examples. Let's straight look at examples. Okay, let's look at examples there that will help us really to understand what we are talking about. Okay, example 1. Convert 1. Let's just start with 0. So 0 0.25 to a number in base 2, to a number in base 2. So as you can see from that table there, 0.25 is equivalent to 0.01. So solution 0.25 base 10 is equal to 0.01 base 2. Okay, using that conversion table there, and you are done, as you can see. Now let's look at how we can convert from base 2 now to base 10, meaning from Bicimals to base 10. So example 2. Example 2. Convert 1 1 0 1.1, okay, base 2 to a number in base 10, okay, in base 10. This is common at grade 9 and it always comes in your paper 1, okay, in your paper 1 section B, okay, to a number in base 10. So what you're going to do here is to say, okay, solution I just want us to get used to this table there, which is very easy to really deal with, okay. When you look at that one, so these values here are very, very important, okay, for us to understand what we're talking about. So let's just go back to the question and see what we are supposed to do. So here I'll say, okay, in the previous video I did how we can convert the whole part of this base number. So we're going to go like this. So here I'll have 1 1 0 1, okay, 0.1. All right, now I want you to take note of certain things here. So this is a base 2 number. So in base 2 we are staying in the powers of 2. Now here we have the whole part of a number and the decimal part of a number. So the decimal part of a number is just 0.1. The whole part is 1101. So we are going to say for the whole part, I'll say 2 power 0 there, 2 power 1 here, 2 power 2 there, 2 power 3 there, okay. Then here I'm going to have 2 power -1 there, okay. So here we're going to proceed as follows. So meaning that 2 power 3 is just the same as 8 being multiplied by 1 plus 2 power 2 is 4 being multiplied by 1 plus 2 power 1 is a 2 being multiplied by 0 plus 2 power 0 is a 1 being multiplied by a 1, okay. So here I'll take this decimal point here to be a plus. So I'll simply say plus 2 power -1 is the same as 0.5, okay, 0.5 multiplied by a 1 there, okay. So meaning this one which has got a 0 is none of my business. So I'm going to say, okay, this is going to give me 8 plus 4 plus 0 plus 1 plus 0.5. From the table there, I want you to just have a look from the table. Let's just have a look from the table there, okay. Have you seen 0.1 here is equivalent to 0.5. So 0.1 there is equivalent to 0.5 there. I hope you are able to see, okay. That is the importance of us coming up with this conversion table. It will really make our work to be easier, okay. So now here we are simply saying, okay, let's just enlarge this a bit. Now what we are simply saying is we're going to say, okay, this is going to give me 8 plus 4 is 12, 12 plus 1 is 13. So here I'm going to have 13.5, 13.5 base 10, okay. Though I haven't written base 10, it will still stand to be true. So that is your solution, Okay, that is your solution. Let's look at another example. Okay, all these questions are coming from ECZ past exam questions. Maths is universal. So let's look at example 3. Example 3. Okay, convert 1 1 1 1.001 base 2 to a number in base 10 in base 10. So this is easy solution. So let's look at solution. So I'll still arrange this according to the powers of 2 since I'm in base 2. So I'm going to stay in the powers of 2. So I'm going to say this is going to give me 1 1 1 1, okay, 0.001. So I'll say this is the same as 2 power 0, 2 power 1, 2 power 2, 2 power 3. Then here I'm going to have 2 power negative 1, 2 power negative 2, and 2 power negative 3. Okay, so straight away here I'm going to simply say, okay, all those that have got zeros are none of my business. So I'll simply say those with zeros, they are none of my business. So I'm going to say, okay, this one I'm not interested, in this one I'm not interested. So these will go because the result will still be 0. So now let's do with those that are having powers of 1. So now I'm going to say this is the same as 8 multiply 1 plus this is just the same as 4 multiply 1 plus 2 multiply 1 plus 1 multiply 1. Now this decimal point I'll treat it as a plus. So plus, now this is 0.5. This is equivalent to 0.5. To negative 1 is 0.5. To negative 2 is 0.25. To negative 3 is 0.125. Okay, so now we can do the following. This is just the same as 8 plus 4 plus 2 plus 1 plus 0.125. So this now is going to give me 8 plus 4, that's 12, 12, 13, 14, 15. So this is going to give me 15.125%. And you are done. You can see that these are very, very simple things. Very simple indeed, straight to the point. So if you can just master the table, then you are helping yourself. And really, there is no much work there. If you can just understand that 0.5 is equivalent to 0.1, and then you can find the rest by just subsequent powering, then you are there. Okay, one last example. If this video is so far helping you to understand, please subscribe, like, and share this video to more people. So last example. Convert 10101, okay, 10101.101, 10101.101 base 2 to a number in base 10, Okay, solution. So solution, this lesson has been a bit long. Solution, so I'm going to use what I have. So 1 0 1 0 1.101. Okay, so here I'm going to say this is the same as 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. This is 2 power negative 1, 2 power negative 2, 2 power negative 3. Okay, so what is happening now is that those with zeros are none of my business, so I'm going to kill them. So this one will go, that one will go, that one will go. Okay, so now I've remained with 2 power 4 is the same as 16, so I've remained with 16 plus let's just be consistent with color there. So 16. So now I have let me just get back to this color. So now I have 16 plus 4 plus 1 plus, now this is 0.5 plus 0.125 there. Okay, 0.5 plus 0.125. So this is 21 plus 0. So when you add those, we are going to have 0.625 there. So this one's going to give us 21.625 base 10. As simple as that. So really, I hope those of you who are in grade 9, these numbers will not give you challenges anymore. And please like this video, share it with your friends in your WhatsApp groups. Let them know that this is happening and they can learn with ease. Really, I'm sure you are going to handle these questions in your exams with confidence. From me, it's Shalom.